is about going over the idea of measures of center. You're probably aware of the three main measures of center already: mean, median, and mode. But what's their purpose? Okay, I'm not going to show you their purpose. Can someone tell me why we might want to know what the mean, median, or mode is? What's the purpose of that? Why does it keep getting taught to you at year 8, year 9, year 10 if it's not that important? You can't tell me. Let's pretend we weren't grouped up as one class anymore. Let's remember back to when you were two separate ones. If I wanted to know which was the taller class, could I just measure everyone's height and then just look at all those numbers at the same time? Can I look at 20 numbers versus another 20 numbers? What if the first number in my list of IG2 was 160 centimeters and the first number in my list for IG1 was 180 centimeters? Does that mean that IG1 was the taller class? No, because are there other numbers to think about at the same time? So now think about it. What if I found the mean height of IG1 and the mean height of IG2? Do I have 20 bits of data in each class now? I've only got one. Can I compare one number to another? That's the purpose of a measure of center, okay? So the purpose of a measure of center is to summarize a whole data set in one number. So we already went through that situation in our minds. We cannot just list the heights in name order and compare the first, second, third students in each. We need a number that exemplifies or represents the whole group in one single number, because you can't compare 20 numbers with another set of 20 numbers at the same time. You can compare one versus another. This is the purpose of a measure of center. So can anyone honestly raise their hand up and thought about measures of center in that way? So can I just, a little bit? Probably you've just seen measure of center. Oh, my teacher's teaching this for the sake of it. No, it's because there's too much data. I need to verse one with another. So let's go over the mean. This is where you should start getting notes unless you remember it already. The mean of a data set is the mathematical center of the data set. And hopefully, year 8, year 9, previously, you've seen that the mean is the sum of all the data values divided by the number of data values. If you're not aware of that, you need to let me know. You need to tell me some names so I can get in touch with them and tell them they did a bad job. These positives and negatives, this might be something that you don't know already. The mean is the most commonly used measure of center. You probably know that. But it's a positive. We use the mean because it involves all the data to calculate it. Do you agree with that? If I'm adding up all the data values, have all the data been used in the calculation of it? Yeah? What is the problem with the mean? We don't always use the mean because the mean is affected by outliers. Do you remember what an outlier was? What was it? Can someone describe to me an outlier? Yes?
A point of data that's like really far away from
Good.
the rest.
So if your parents or you are interested in house prices, right? Do you know where Brighton, the suburb, is? Is that right next to the beach? Do you think it would be a good idea to use the average house price in Brighton to tell you how expensive homes are there? You reckon? What do you reckon the price of houses are right next to the beach? Expensive. It doesn't give you a nice idea of the general price of houses in Brighton because it's being biased from a very small collection of houses. We got a similar situation here in Aberfoyle Park. The more expensive houses are up in the hilly part, right? So when you do house prices, people tend to use median instead because it's not affected by outliers. Okay? So that's the mean. Just make sure you have the formula for it, sum of all the data values, and then you could dot point the positives. It's most commonly used, and also it's because all the data is used to calculate it. What's a negative? It's affected by outliers. The median, on the other hand, and this may be where you need to get the formula down, The median of a data set is the positional center. The mean was the mathematical center. Literally, we're talking about the middle. This is the median of this room. Did I use maths to do that? No, it's just a position, okay? The median of a data set is the positional center of the data if the data is in numerical order. So if you're not already aware of this formula for finding the median, I'll give you time. Can you get the formula down in this box? For a data set with n data values in it, the median is the number in the n plus 1 over 2th position in numerical order. So before you even find the median, you need to put the numbers in numerical order, small to large, then count how many bits of data there were, add 1 to it, divide that number by 2. That's not going to tell you what the median is. It's going to tell you where to find it. Okay? And then lastly, if n is even, the position of the median is going to be between two numbers. In this case, the median is the average of those two numbers. So you're probably freaking out and going, what the hell is he talking about? Let me show you. If I had these numbers, 1, 2, 2, 3, 4, 5, where is the middle of that? Where is the middle position of that? Is the middle of that one of the numbers, or is it between two? The median is between two. And so this note here is trying to explain if the number of data is even, the position of the median is going to be between two. So in this case, the median is going to be the average of 2 and 3. What is the average of 2 and 3? Good. And then let me demonstrate that formula. How many numbers are there here? 6. So the median is going to be 6 plus 1 over 2th. 6 plus 1 is 7. 7 over 2 is 3.5th number. Do you agree that I've drawn this arrow in the 3.5th position? Because the third number is 2. The fourth number is 3. 3.5 is halfway between the two middle ones. Right, so you get that. The positives, the median is not affected by outliers. Let me give an example there. I can literally, if I changed 5, right? If I changed 5 in that data set to 50, do you agree that 50 is an outlier? Yep. Did that affect the median in any way whatsoever? No. But if I found the average of those numbers, if I found the average of 1, 2, 2, 3, 4, 5, would it be like 2 and a bit? Something like that? Just 1 plus 2. Let's do it in our heads. 3, 5, 8, 9, 10, 11, 12, 13, 14, 15, 17. 17 divided by 6. Just over 3. Okay, so that gives you an idea of, that's pretty good within those numbers. But if
just shy of 3.
Just shy of 3, so 2 point something. That would be the average if it was 1, 2, 2, 3, 4, 5. But let me demonstrate. If I made that number 50, median completely unaffected. The median remains at 2.5. Can you quickly find what the average would be if that fifth number? You're not going to be able to do that in your head. Something like 10. See how the mean was affected by that? So that's to demonstrate how the mean and median are affected differently. What is the negative of the median? Are we using any of these numbers to work out what the median is? No. You're just working out where things sit. So that's a bad thing about the median. It only involves the data in the middle. It completely ignores 1 and 5. So that's a good thing sometimes and a bad thing other times. Any questions about that? The last measure of center is the mode. The measure of the mode of a data set is simply the most common data value. I'm not going to give you formula. Just friggin' look at it. Which is the bit of data that happens the most? If you have more than one bit of data that happens the same amount of time, you would say it's multimodal. Okay? Positives, the mode is easy to find. Negatives, the mode is not meaningful compared to the mean or median. Okay? So if you haven't yet, 3 formulae: mean, sum of all data divided by the number of data. Median was the more complicated one. Formula for the mode, there is no formula. Look. All right, I'll give you some time. Can you get that down? And then I want to demonstrate. You're still getting that? No, I'll move on. Let's demonstrate this. Number of planes flying to a remote airstrip over 15 days is below. You can see the numbers there. I'm not going to read them out. For this data set, find the mean. Can we find the mean straight away? Do I need to order the numbers to find the mean? No. So add the mean equals, so we're answering A here, 5 plus 7 plus 0 plus 3 plus 4, 6, 4, 0, 5, 3, 6, 9, 4, 2, 8. Divided by how many numbers there were? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Divided by 15. Grab my calculator out. 5, 4, 5, 7, 0, 3, 4, 6, 4, 0, 5, 3, 6, 9, 4, 2, 8, 66. 66 over 15, your mean 4.4 is the mean. B, median. Can I find the median straight away? No. I need to order it. So, in red, what would the first numbers be? 0, 0. Is that the number? Is that the end of the zeros? I think so. How many? What's next?
2.
Next?
3.
How many?
2.
Next?
4. 3.
Yep. Next?
2 5s.
Next?
2 6s.
2 6s. Next?
1 7 1 8 1 9.
Yep. Thank you. So that's it in order. The formula that I've given you is n plus 1 over 2 Earth position. What is n? 15 plus 1 over 2 Earth. 16 over 2. 16 over 2 8th position. So I count across 1, 2, 3, 4, 5, 6, 7, 8. Why is this not between 2? There's an odd number of data. So in an odd number of data, there's going to be one number in the very middle. Okay, so you don't need to do any working out. So median is 4. Mode. So C, mode. What's the formula for the mode? Just freaking look. Which one's the most common? 4. Okay. Can you get that working out, please? I'll stop the video there because I've got a second.